So today we are going to solve day 25 problem of this month on Leetcode. Before starting, if you guys haven't subscribed my YouTube channel yet, then please go ahead and subscribe it. Now without any delay, let's get started with today's problem. Problem number 2040. Kth smallest product of two sorted arrays. Let's read the problem statement first. We have given two sorted zero indexed integer arrays nums1 and nums2 as well as an integer k. We have to return the kth one waste smallest product of nums1 of I into nums2 of j, where I is greater than equal to 0 and less than nums1 dot length, and j is greater than equal to 0 and less than nums2 dot length. Okay, so we are just multiplying two numbers. Okay, we are taking one number from a nums1 array and we are taking another number from nums2 array, right? And we are making sure that their product, okay, it should be minimum 1, and we need to return the kth smallest product. Okay, so we are doing the product like here. If you see in this example number 1, so from here nums1 you pick 2 and from this nums2 you pick 3. Okay, this is one way. So 2 into 3 you are going to get 6. You can also pick 2 from nums1 and 4 from nums2, you are going to get 8. You can also pick 5 from nums1 and 3 from nums2, you are going to get 15. Okay, and you are also going to pick let's say 5 from nums1 and 4 from nums2, then you are going to get 20. Okay, we have to return the kth smallest. Okay, and it is one based. Okay, smallest product of this. All right, so one based, simply this is 1, this is 2. Okay, if I just sort it 3, okay, 6, 8, 15, 4. All right, so now k is 2, so for 2 we see this output 8. 8 is our output, that's it, right? The two smallest products are nums1 0 into nums2 of 0, 2 into 3 is 6, 2 into 4 is equal to 8. The second smallest product is 8, right? So here we are dealing with the products, right? Okay, so and one more thing here, array is sorted. Okay, array is sorted, so 0 index, and it is 0 index integer array, right? This is 0 1. Okay, now if you see this example number 2, this is our nums1 array and nums2 array, and here k is equal to 6. Okay, there are many ways. So now here you see negative numbers are there. Okay, negative numbers are there. So minus 4 into 2, if I'm doing, I will get okay minus 8, right? And here if I do minus 4 into 4, then I'm getting minus 16. All right, so we are getting minimum number. Okay, this is going to the minimum, right? You can try other possibilities also. Minus 2 into 2 is nothing but minus 4. Okay, and minus 2 into 4 you are going to get minus 8. Okay, so we are going to get the minimum number when we are going to multiply the minimum negative number with the, okay, minimum negative number mean, okay, mean with the max positive number. Okay, so when we are going to do this, okay, minimum negative number with max positive number, then we are always going to get the minimum value, right? So this is just one case, right? If you observe this here, right? And max we are going to get when, okay, so this is for mean, right? Minimum number. Okay, or okay, when we are going to get max, so when we are going to multiply max positive integer from one array with the max positive integer from another array. Okay, max only, then we are going to get max always. And there is one more scenario now, we can get max positive max positive value also when we are going to multiply the mean negative integer. Okay, mean negative integer from one array with mean negative integer from the another array. Okay, so here if you see, let's suppose in nums1 minimum is minus 6, and let's suppose in num2 minimum is minus 7, so you are going to get 42. Okay, max value, right? Okay, so these are just little bit scenarios, right? So here in this case, if you see, we have to find the k is equal to 6. Okay, sixth one, right? So minus 4 into 4 minus 16. Okay, minus 4 into 2 minus 8, then minus 2 into 4 minus 8. Okay, minus 2 into 2 minus 4, then 0 into 2 0 only, 0 into 4 0 only. Okay, so k is equal to 6, right? So here output is 0. Okay, so 6 smallest product is 0. Okay, now example number 3, this nums1 and nums2 and k is equal to 3. Okay, so see, k is equal to 3. Okay, smallest we are going to get when we are going to multiply minimum from one array and max from another array, right? So minus 2 into 5 minus 10. Okay, and you can also see this minus 2 into 4, then you're going to get minus 8. Then here also 2 into minus 3 minus 6. Okay, so k is equal to 3, so that is why you are returning this minus 6. Okay, so this is what we are actually doing, right? You are clear, right? Why what we are returning? We are returning the kth smallest product. Okay, kth smallest product of two sorted arrays. Okay, arrays are sorted. All right. So here, if you see problem statement itself, we are talking about the kth smallest product. Okay, so we have some range of answers. All right. Okay, so among them we have to find out the kth smallest. Okay, so what I can do here, I can simply think about binary search. Okay, so here if you see the constraints, nums1 of I value is from minus 10 raised to power 5 to 10 raised to power 5. Okay, and nums2 j value is also from minus 10 raised to power 5 to 10 raised to power 5. Okay, so here minimum value, okay, I'm doing the multiplication, right? So minimum value, when I'm going to get minimum value, what I'm going to get, so here 10 to the power 5 into 10 to the power 5. Okay, and the negative of this is the minimum value that I can get. Okay, so if I multiply, let's suppose negative of this with the positive of this max, I'm going to get the minimum value, right? And max value, when I'm going to get, when I'm going to multiply 10 to the 5 with 10 to the 5 max. Okay, so I can say that this is my low and this is my high, and then I'm going to calculate the mid of these two. Okay, so mid of these two, how you're going to get? So simple formula, right? Low plus simple binary search, high minus low, and here divided with 2. Okay, so what you are going to get, you are going to get 0 only, right? Why 0? Here this is a low, right? So minus 10 raised to 5 into 10 raised to 5, you can say minus 10 raised to power 10 plus, and here high is 10 raised to power 10. Okay, and here low is minus of 10 to 10. Okay, and it's half here. So here minus 10 by 10 plus 10 to 10 plus, okay, minus plus 10 to 10. Okay, so 2 into 10 raised to power 10. All right, and here 2 cancel out these two, you are going to get minus 10 to 10 plus 10 to 10, you are going to get 0 only mid. Okay, for mid, initially your mid is going to be 0 then. Okay, but this is just the range. Okay, so be binary search of the range of possible products, and for each mid product, guess count how many pairs from num1 of I into num2 of j are less than equal to mid. Okay, so this is our binary search, right? So how binary search works, so let's say this is your low value. Okay, this is your high value. Okay, and now this is going to your mid. Okay, so you apply the formula, you get some mid. Okay, so now you are going to check how many answers are possible with this mid. Okay, how many answers are possible with this mid value. Okay, how many products, okay, how many products you are going to get which are less than equal to this mid. Okay, this is what you are going to check. Okay, how many number of products which are less than or equal to this mid. Okay, so we are going to get some value. Let's suppose we are going to get some value here. Okay, so let's suppose here uh, you can say that this total is total from here to here, let's say 20 answers possible. Okay, and here 0 answers, and you are finding a k for 16. Okay, 16 answers you are finding. Okay, and in the mid you are going to say 0 plus 20 minus 0 divided by 2, 10. Okay, 10 answers possible. Now here in this range, k value is not exist, right? K value is not exist in this range. Okay, so next time you are going to search in this range. Okay, so next time your low is going to be mid plus 1. Okay, so this is your next time low, and here this is high. So in this range, low is you can say 11. Okay, and high is nothing but a 20, right? And 11, again you are going to get the 20 minus 11 divided by 2, so you are going to get 11 plus 9 divided by 2, and here is nothing but 4, so 15 you are going to get. Okay, with 15 you are going to check answer is possible in this range or not. Okay, how many answers are there? So we are searching for 16, so definitely that exists in this range. So 16 to 20 you are going to do the binary search. Okay, so this is just the functionality of binary search, how it works. Okay, very simple, very simple part. Okay, so the smallest possible product is, we already know, we are going to get when minimum for nums1 with the min of nums2. Okay, when we are going to do this. Okay, so this is in case of positive integers. Okay, so here in nums1 is positive and nums2 also positive. Okay, then we are going to get min. But there is one more scenario, if min of nums1 into max of nums2. Okay, so this is the case where, let's suppose this is negative and this is a max. Okay, so when one is negative, okay, so depending on negatives. Okay, so this is our search space, right? And the largest possible product is when we are taking max from both sides, or min. Okay, so here is also negative, let's say here is also negative, then in case depending on the negatives. All right. Okay, then after that we are just going to apply the binary search for a given mid. Check how many products which are less than equal to mid using a helper function. Okay, so we are going to apply the binary search, right? And here first this part only. Okay, ignore this part right now. So this is the main part. Okay, so here based on constant, you already know that nums1 nums2 minus tends to 5 tends to 5. Okay, so that is why we are taking low, this as low and this is high. Okay, so let's write the code for just this two part. Okay, until here, then I will explain further. Okay, so this is simple binary search. Okay, so lowest value, what is going to be lowest value? Lowest value is going to be constant size, if you see. So minus, and here you can say 100 underscore 000, and here L. Okay, long, right? And here into you can just simply copy this, okay, and paste it here. Okay, this is the lowest value. Okay, and high value you need to have in binary search. Okay, so how you get that? Long high is equal to, and here just take these two. Okay, just copy this, paste it here. That's it. Now how you apply the binary search? So while low is less than high, okay, then in that case you get mid as long. Mid is equal to low plus, and here you have to just simply do high minus low, and here divide it with the 2. Okay, this is how you are going to get mid. And then you have to check if count pairs. Okay, how many pairs? Count pairs. Okay, this is a method that I'm going to write. Okay, so count pairs less equal, and here you have to just pass your nums1 array. Okay, nums1 array, you have to just pass your nums2 array. Okay, and the range. Okay, this mid is nothing but a target. Okay, so how many pairs which are less than equal to this mid? Okay, so if this value, okay, it comes out to be less than k. Okay, if it comes out to be less than k, right, this value. Okay, so in that case you know that. Okay, so here I have spent if the values come out, okay, less than equal to k. Okay, so somewhere here, but your k value lies somewhere here, so then you have to update your low as mid plus 1. Okay, so here low I'm going to update it as mid plus 1, right? And else part. Okay, so if this is your range, low and high, and mid is here, okay, and your k value is somewhere here, then then that simply means your answer lies in this part. Okay, so next time your this high you are going to set it to mid only. Okay, then you are going to check this range. Okay, so else part. Okay, so if the value here comes out to be greater than equal to k, okay, and greater than equal to k, but your k lies somewhere here. Okay, so in that case your else part, you just update your high as mid. Okay, that's it. All right, so now I am okay, so from here you can simply return low value. Okay, so low is going to contain the answer. Okay, so I am expecting this to check everything. Okay, but here this is the basic structure of this code. Okay, so now we have to just write the code for this count pairs less equal. Okay, and this is also going to be very simple, nothing complex here. So for this first let's write one method, private long and count pairs less equal. All right, and here just pass your values. Okay, in nums1, in nums2, and then after that just pass the, okay, mid. You can say this is nothing but your target. Okay, which you are going to check. All right, so now here inside this, let's understand what is going to happen. Okay, so this is very simple. Okay, this basic part. All right, so now after this, if you read this point, okay, so if a value is greater than 0, then use binary search in nums2 to find how many b's satisfies a into b less than equal to mid. Okay, so here let's suppose this is your nums array. Okay, so you can take this example 2534. Okay, 2534, and here k is equal to 2. Okay, so first let's suppose this is your a. Okay, this 2 is nothing but your a. Okay, then for this a you have to find out the b's, okay, such that when you multiply this a, okay, with the value here, with some value here, so it should be less than equal to your target. Okay, target. All right, so what I'm saying here, so see here, you are applying this binary search, right? So low, high, and mid. Okay, so first time when you are going to apply this same thing, okay, here, so your target is going to be 0 for first time, and I already explained why. Okay, low plus high minus low, here you are going to get 0 for very first time. Okay, so now count for target is 0, so total valid pairs are 0, right? Because this time if I multiply this 2 into 3, I'm getting 6, I'm getting 2 into 4 8, I'm getting 15, I'm getting 420, right? So none of the values are less than equal to 0. Okay, so total value pairs are 0, right? So mid is equal to 0, count is equal to 0, low, high, this. Okay, done. Then next time 0, right? So in this range, low, high, mid. Okay, and when I did, I get 0, right? But I need 2. Okay, right? So that means that here it lies somewhere here. Okay, so what I'm going to do next time, so next time I'm going to, here if you see, my low I'm going to update it to mid plus 1. Okay, mid was 0, so low plus 1, so that is why low is equal to 1 and high it is going to remain as it is. And now I'm going to calculate the mid, so I'm going to get mid somewhere here, right? And this is the target. Okay, until here I'm checking, so until here all are possible, right? So count is equal to 4. Okay, so total valid PS is equal to 4. Okay, count for this target 4 is coming. Now see, in this big range, okay, in this big range, okay, this was my low, this was high, somewhere here mid. Okay, so I see that until mid my answer is possible. Okay, until here my answer is possible. Okay, 4. But now I want maybe my answer, if I decrement my mid value something left, maybe there I can find the answer. Okay, I have to find the minimum value, right? Here if you see, kth smallest product. Okay, smallest product we have to find. Okay, kth smallest product of two sorted arrays. So here in this range answer is possible, but I have to find the smallest one. Okay, so here I'm going to set it to low, and next time this high I'm going to set to this mid I'm going to set to high. Okay, now again for this mid I'm going to check, so again my answer is going to lie here. Okay, so next time if you see, now see this part. Okay, so low is this and high I'm setting it to this, and mid I'm going to get this. Again my answer is possible. Okay, so here step by step I'm doing the same thing. Okay, again and again I'm going to do same thing. Okay, and every time I will see my answer is possible. Okay, everywhere answer is possible, everywhere answer is possible. Okay, okay, here also answer is possible, here also answer is possible. Okay, here also answer is possible. Now here if you see, if when my high becomes 75. Okay, so this is like this. So first time I move here, then I break it here, then here also answer is possible, then here also answer is possible. Okay, breaking it. Okay, little bit, right, like this. So here if you see, next time, now if you see this line. Okay, so here high is 75, low is equal to 1. So if you do mid 38, again total valid pairs are 4. Okay, so now I am thinking that here if you see, I just draw this. Okay, let me just draw this part. So here I can simply say, your high is 75. Okay, high is 75. All right, and your low is, let's say, 1. Okay, then mid is coming out as, let's say, 38. Okay, mid is coming out as 38. So now again answer is possible. Okay, you are getting 4 pairs. Now I am going to look in this side. Okay, maybe more smaller value, with more smaller value answer is also possible. So next time my low is 1 and high is 38. Okay, low is 1, high is 38. Now from here I do the mid, so mid is 19. Okay, now with the 19, here mid is equal to 19. I see the total valid pairs are 3 only. Total valid pairs are 3 only. Why? So here 2 into 3, 6, 2 into 4, 8, good. 5 into 3, 15, good. 5 into 4, 20. Okay, that is why only 3 are coming up. Okay, so only 3. Now then that simply means that until here, until here, uh, 3 valid pairs are coming, but what is my k value? My k value is 2, right? So I can again decrement. Okay, again I go to this window. Okay, so low is this, so this was mid. Okay, so I'm going to set this mid as high and low here. Okay, so low is 1 and high is equal to 19. Okay, now again in this mid I'm going to get 10. Okay, so with the 10, how many answers are possible? So count for target is equal to 10, and total valid pairs I'm getting 2. Nice, now I'm getting 2 only. Okay, which is the requirement. Okay, but here I am again going to check further. Okay, so until when I am going to do, okay, until when I'm going to do this, until my left, this here low is less than high. Okay, until then I'm going to do this. Okay, so now here, until 10. Okay, so I'm just applying the binary search on answer, right? Nothing complex here. All right, so with this 10, now again in this part I'm going to check. So next time low is 1, high is 10, mid is 5. Okay, with 5 we are getting 0. That is bad. Okay, we need to. So now this time, what I'm going to do, I'm going to update my low as mid plus 1, that is 6. Okay, and high 10. Okay, and with this I'm going to get 2 again. Okay, then next time again I'm going to check high 8, low 6. I'm going to get 1. So in the end, this my while loop is going to end, and I'm just going to return my output as 8. Okay, so here last time, you get for this 2 8. Okay, so this is the one, right? So 8 you have to simply return. Okay, so now let's do one thing. This is clear. Okay, so now here, all right, so this is one thing how this debug is happening. One more thing that I want to explain here, this part. Okay, if a is greater than 0, then what is going to happen? If a is less than 0. Okay, right now I'm taking this as a, then I'm checking all the b's from here, this, then I'm taking this as a, then I'm checking all the b's. Okay, all this stuff. So if a is greater than 0, okay, so here let's see this part. Nums1 is equal to 2. Okay, and this is a nums2 array, target is 10. Okay, so if a is equal to 2, that is positive in this case, so we want all the products where 2 into b I'm going to do, and I will get value less than equal to 10. Okay, this is my target. Okay, so manually if we check, so 2 into 1 is 2, 2 into 3 is 6, 2 into 5 is 10, 2 into 7, 14. Okay, so valid b values are 1, 3, 5. Okay, 3 values. So we want binary search to find that index left is equal to 3. Okay, so count is equal to count plus 3. Okay, so 3 values. With the 3 values, this nums1 is making pair, right? Okay, so this we check manually, but however binary search is going to work. So first this I'm going to check. Okay, this is my a value. Okay, this is positive, and here this nums1 starting index this and max index is 0, 1, 2, 3. You can say 4 nums total length. Okay, 4, right? So total length is 4, so I'm going to take this as max. So among them I'm going to get mid. Okay, so I'm going to get some mid value as 2. Okay, so at 2 index we have 5. Okay, so 2 into 5 if I do, so I'm getting output as less than equal to 10. Okay, my target answer is possible, right? This is 0, this is 4, and with this 2 answer is possible. Okay, now what I'm going to do, okay, with this answer is possible, right? So here this is low, this is high, and this is mid. Okay, so at mid index if I keep, the answer is possible. Okay, so now what I want to do, I maybe there are more pairs with with those answers also possible. Okay, so what I'm going to do, I'm going to check in this range. So I'm going to update my low as mid plus 1. Okay, so my low is going to become 3 now, and high is going to remain as 4 only. Okay, so here 3 plus 4, again I'm going to, so nums2 of 3 I'm going to get 7. Okay, so at 3 index we have 7, right? So now if 2 into 7, so I see answer is not possible. Okay, so what if this with this answer is not possible? Okay, so in this range it is saying that answer is not possible. So what I'm going to do now, I have to okay, so this is my low and high. Okay, so let me draw it here. Low at 3 and high is at 4, and I get some mid. Okay, so my mid is also at 3 only. Okay, so with this answer is not possible. Okay, so now what I'm going to do, I'm going to set my high to mid. Okay, this right to mid. Okay, so here both left and right becomes equal to same. Okay, at same position, so we can simply end the loop. Okay, so in the end you see that my this means left and right both are equal to 3. Okay, so 3 elements in the nums2 produce a product which is less than equal to 3. So in the count I'm just going to add left. Okay, so this is very clear, right? Positive, here I'm talking about where a is positive. Okay, so right, so here this is the range. Okay, with this answer is possible, then I'm checking further. Okay, maybe here also answer is possible, right? Bigger values, right? Okay, so we need all the possible products, right, in this range. Okay, so now if you see in this case, okay, where nums1 itself is negative. Okay, and here target is -10. So now if you do here, we are trying to count how many products of the form -4 into b. If I do, I get less than equal to 10. Okay, this is what we are basically checking, right? So we walk through the logic for a is equal to -4. Okay, this value, so -4 into b. Okay, so here if you see, if I place b value greater than equal to 3, okay, greater than equal to 3, so what I'm going to get, -4 into 3, I'm going to get 12, -12. Okay, and -12 is less than equal to -10. Okay, and here -4 into 2 is going to, I'm going to get -8, and -8 is not less than equal to -10. Okay, -8 is bigger than -10. Okay, negative values are there, so we need the count of b greater than equal to 3 in nums2. Okay, so that is nothing but in nums2, which is nothing but 2, 3, 5. So among them 3 and 5, with 3 and 5. Okay, so count of b, but we need here, we need bigger than 3 value, right? 3 or 3 bigger than 3. Okay, so these are 3 and 5, so count is 2. So now let's simulate the binary search in the code for this one. Okay, so this is the case where a is negative. Okay, so here left is equal to 0, right is equal to 3, right? So this is your nums array, right? Size is 3. Okay, so again mid you are going to get okay, so mid index you are going to get 0 plus 3 divided by 2, 1. So nums of 2 is equal to 1, 3. Okay, so with this 3 you're going to check, so -4, 3, answer is condition satisfied. Okay, so now here this is a negative side, right? This is a negative value of a. Okay, so here this is 0, this is your 3, and here in the mid you are going to get 1 mid. Okay, so now until here answer is possible, right? You have negative value. Okay, so now what you are going to do in this case, you are going to update your right as mid plus 1. Okay, right as mid plus mid only. Okay, so high. Okay, if you take a low, or you can also say left or right. Okay, no issues. So mid you are going to update as right now. Okay, with this side, why we are moving this side? Okay, so for positive a, increasing b increases product, but for negative a, increasing b decreases the product. Okay, so we have to adjust binary search accordingly. So for a is less than 0, we look for the first index where a into b is less than equal to target is true. Okay, first index we are going to check, then the result is going to be nums2 dot length minus left, because all values from left to the end of array are valid. Okay, so for this scenario we are going to take this side. Okay, so that is why my right is going to be move mid. Okay, so next time mid is equal to 0 plus 1 divided by 2, you are going to get 0. Okay, so -4 into 2. Okay, so answer is not possible, so move left is equal to mid plus 1. So in the end left is equal to right is equal to 1, both becomes equal, so we have to stop, right? So final answer is equal to nums2 dot length minus left. So here nums2 dot length 3 and -1, so what is the value that we are skipping? So we are skipping this side, okay, right? We are skipping this one, okay, because with this we are getting bigger values, okay, because this is negative, right? So in this we need just this, okay. So what we are doing, so total length comes to dot length and minus left, okay. So until here we are just stopping, so we are going to get 2 here, 2 value pairs, okay. So let's write the code, very simple, nothing complex, okay. So you just have to practice it, okay, by yourself also one more time. So code is very simple, code is very simple. Long count, okay, this is what we need to check, okay. Count is equal to 0. So here we have just iterate over all the values, okay. You can use for each, okay, in nums1. All right, and here inside this you are just checking if a value is greater than 0, okay. So if this is the case, and then you have to take int left is equal to 0, right is equal to nums2 dot length, and here you have to just do while left is, here also you are applying the binary search, only left is less than right, okay. And here again you are going to get mid, okay. So mid is nothing but left plus here right minus left, okay, divided by 2, same like above, okay. And then here now you are going to check if, okay, long, okay, we are just going to change the value to long a into and nums2, okay. And what is the mid value, okay, since arrays are also sorted, right, and we are talking about case, so definitely binary search should come to your mind first, okay. Here if it is less than equal to target, okay. So if with this answer is possible, then maybe some in the right side maybe some bigger values also there, okay, maybe more products we can form. So mid plus 1 I'm going to do, okay. And if not, then here I'm just going to do right is equal to mid, okay. And here we have to just do here you are for this while loop ends, okay. Here you have to just simply do count is equal to count plus left, okay, right. So this is for positive, right? So for positive, here this side we are picking, okay, this side, okay, until here. But for the negative we are picking this side, so nums dot length, nums2 dot length minus left we are doing, okay. So same code I'm just going to copy paste here, but just you need to change the this first heading, a is less than 0, okay. So if a is less than 0, then what you need to do, just copy this, nothing else, copy this, control C, and here just do control V, okay. So here int left is 0, right is this, while left is less than right, mid you are going to get, and here you are just going to multiply, and here since this is negative case, okay, so here you have to write right is equal to mid, okay. And here you have to write left is equal to mid plus 1, and here how you are going to update the count is nothing but nums2 dot length, 2 dot length and minus left, okay, done. And this is for this, and in the else part, simple, when a is equal to 0, okay. So when a is equal to 0, so definitely if you multiply any number with 0, answer is possible, okay. And make sure your target should be greater than 0, okay, only then you are going to count those, okay. So if a is 0 and your target is also, okay, in the else conditions, definitely I'm talking about a is equal to 0, so target, okay. So if your target is also greater than equal to 0, okay. So in that case you are going to count everything, okay. So count is equal to count plus nums dot length, okay, nums2 dot length, right, that's it. And here from here simply return count, that's it, okay. So now let's run the code and see if the code issues. We'll try to fix that. So the test case has been accepted, now let's submit it. So see, our solution is accepted, right? So I hope that you guys are able to understand today's problem, and if you guys still have any doubts, then please feel free to ask in comment section. Till then, keep coding and keep practicing. Meet you in the next video. Thank you, bye bye.